Hi, good afternoon, everyone. My name is Harsh. So we are just going to start the webinar in next 1 minute or so. So we wait for some of us to join. So today we are going to be talking about customer churn reduction, how you can reduce the churn of your customers the most effective way. Now, I'm not going to lay out the broad strategies that, okay, do good customer onboarding, make your customers happy. None of that general advice. So we are going to very specifics. We are going to find out how and why exactly each customer is churning using machine learning. I'm going to be using our no code platform, as well as we'll have the probabilities for every customer to churn. And in the end, I'll be also doing survival analysis. So this is something I've not touched in my past webinars. So a little more emphasis on the survival analysis. And the survival analysis will basically be telling us, look, what is the in how much duration is somebody going to be churning. So that is what I'll be looking at. So with that, guys, I'm going to get started. I'm going to share my screen. If you have any questions and comments, please put it up in the chat. I'll take them afterwards. This is going to be a half an hour webinar. So after I'm done with half an hour, I'll be taking up all the questions, comments. So sharing my screen. If there's any problem in the audio or the video, do let me know. Or if there's any problem in the screen sharing, do let me know. Perfect. So I'm sharing my screen with everyone. You can see my screen. I'm going to hide this one. Okay, perfect. Any problem, let me know. So my name is Harsh Gupta. I'm the head of AI at Cliently. And Cliently is basically a no-code machine learning platform for sales and marketing teams. So they get predictions, they get dashboards. It's all automated for them. So this is where the data science team in the Cliently is striving for every day to make the automation of machine learning as much as possible. So today's agenda, I just talked about it, customer churn, a hands-on workshop, and then I get the prediction of churn with probability. I have the mean residual lifetime, which I'll be discussing in a while. And then we understand the key drivers behind the churn. And finally, we have an action plan to reduce churn for down to every customer. What is customer churn? When people unsubscribe to your product or services in a certain time frame? Usually what I've seen is that most of the industries have this 1 year period where, okay, if you don't come back, if you don't subscribe to the package or the services or the product, you're being called churned. So why is it problem? Why are we not okay with churn? Number one, because acquiring a new customer is 4 to 8 times more costly. Number two, bad word of mouth. I'm not happy with your product. I'll be talking bad about your product other places, as well as I'll be putting up bad reviews on G2, Captera, all those platforms. So it means bad reputation. The newer people that come to your door, they're going to look at the reviews and say, this is not a good product. No new customers from referrals. Think about it. You have few customers, they're always going to be referring. Now it's not going to be the case. So traditional ways of reducing churn. Now we talk to a lot of businesses, especially software as a service businesses. I'm on many sales calls, and most of them, and this is what I hear, and that is what I'm trying to summarize here. Most of them will say, "Oh, we are consulting the gurus or the consultants, and they're charging us many thousands of dollars, and they're giving us the top 10 ways to reduce the churn." Some people call even themselves the chief churn crasher, the new title that I'm seeing. And what are they doing? They're exactly giving you generic advice. Well, to some extent, that is good. Like you need to have good customer onboarding, etc. But that still does not solve understanding the psyche of the customer. Why are they leaving your business? Relying on intuition, just bad. Relying on the red flags, just bad. And even more worse is that you're being very reactive. So once somebody has churned, they have not resubscribed to your services. Only then you're making a phone call. Now they're gone, done, can't do anything. Okay, so why machine learning? Why we should be doing machine learning? So we need to be proactive. We need to understand well before somebody is thinking about churn. We need to capture that in the data, and we need to have those predictions so that we can stop it. We can take an action plan. We need to predict when they will churn as well. That is super important. Okay, so two people have 0.95 probability of churning. Oh, but one person is churning in next 3 months and the other person is churning in next 2 years. Now, my strategy is going to be very different for both of them. So super important that we also get when are they going to be churning. Okay, so a key concept I've those of you who are attending my webinars regularly, I've never discussed this topic. This is the first time I'm bringing it in. So, what is survival analysis? Basically, I use survival analysis to get the mean residual lifetime of customers. When is my customer going to churn from today? Okay. What so in a normal churn probability, all I get is a probability 0.95, zero point 0.6, zero point 0.4, zero point 0.3. But in this case, I want to be more specific. I want to understand that Mr. John Smith has a probability of 0.95. Good. But when is it going to be churning? So with the survival analysis, I can have answers to it. I can get a number like he's going to be churning in 36 months from now. Okay, great. Now I can come up with a strategy. So the big part about so before you do the survival analysis, you have to address the censoring part. There are three types of censoring: right, left, and interval censoring. Let me get to it in a while. Actually, let me get it right now. So most of the time, you're going to encounter right censoring in your data set. If you do so, and that is again the beautiful part about the survival analysis. In a normal churn analysis, you don't consider censoring into account, but in survival, you consider censoring into account. So what is a right censoring which you encounter most of the times? So I want you to look at this data set. There is subscription date. Guys, by the way, any questions, please put it up in the chat comments. I'll take it after the webinar. So just keep posting. So subscription date is April 2017 for customer X, and I know the end date of this customer. But for customer Y, I do not know the subscription end date. So subscription duration is 24 months. Is the subscription is still active? Yes. But I have no idea when is it going to end. So in a normal churn modeling, I would not have taken this observation. Because I do not know. I have to give enough time to observe the end date. I'm not giving it here. So this is where the censoring comes in. Most of the time we see right censoring, and this is where we address it. So we could move forward with a duration of 24 months of customer for Y, which we normally do in a churn modeling. But this would be underestimating the survival time. So the problem is alleviated using survival analysis since censoring is considered. Now you don't have to worry about how exactly we need to do the censoring. For that one, we have the code automatically with every survival analysis model. So you look at all these models, you can run all of them, survival analysis models, and you can tell the code, look, I know this data is right censored, so take that into account, and that code will automatically take that into account. And then there's left interval censoring as well. I'm not going into details because I'm short on time. I have to cover a lot of things, but I'll be sharing the slide with everyone. So in your free time, you can go through the slides. Okay, so done with the survival analysis and explanation of it. Now I want to come at the overview of the machine learning process. So what will the end-to-end machine learning process look like for me when I'm predicting customer churn and when I'm trying to solve that churn modeling problem? So first of all, I have to decide a cutoff date and I have to take historical data set. So let's say my business has been in existence for last 10 years. So I'll take data starting from 2016 maybe, and I'll observe it until 2019, 2020. So, and I have to decide a cutoff that, okay, if the customers came in after 2016, I'm only considering those customers. And if they made an exit before 2019, if they removed their subscription before 2019, I'm considering these people. And of course, the people who are still continuing, who joined in 2016 or afterwards, and are still continuing from 2019 or afterwards. So I decide a cutoff date 2019 September, let's say, is my cutoff date where I'm observing churn. 1 row per customer data set. Most of the times we are going to see transactional data set. So it would be like $22, date paid, uh, date the invoice was sent, from where the person paid. So I have to aggregate all that to make it 1 row per customer data set. I cannot use transactional data set. Okay, so once I have that, what do I do next? So I'm going to clean the data. I'm going to prepare it for the modeling. I'm going to look at all the problems that the data set potentially has. Then I have to do feature engineering. I have to create more features out of the current variables. Then I try a lot of machine learning models. After that, I'll be hyperparameter tuning. So the way I look at hyperparameter tuning is, suppose at a frequency, there's a radio at a frequency 93.5. Now I'll be playing around a little bit. For example, I may play around 93.56. I may play around with 93.5559 to see that at which certain tuning I get the best results. So this is what is hyperparameter tuning. You just check, like, change the parameters to see at which model you get the best accuracy. And then you have survival analysis. So I'll be again going through more on this one. Okay, so once you're done with the model building, what is next? To an executive, you can't just give the numbers. Look, this is the probability of churn. This is when we think the customer will churn. You also need to come up with a strategy, a long-term strategy. So overall, like, where is the problem? If the customer is waiting more than 9 minutes, then you suddenly see 30% increase in churn. So then it needs to be fixed over the long term, making somebody wait over 9 minutes. You need to understand the drivers behind the churn. The short-term strategy would be that you score and find out the people who are about to churn, and then you take immediate action to reduce churn. So that is another thing in short term. Okay, so now it's the time to look at the data set. Give me 1 minute. Okay, so this is a data set, a very popular data set, a telecom data set. It's available on Kaggle. So there is sex of the person, senior, if they're senior or not. And the event of interest here is churn, if they're churning or not. Then there's total balance, paperless, etc., contract. Now, what I'm going to be doing is, remember, I have to do two things here. Number one, I have to build generic machine learning models. So I'm using our no-code automation platform because this is much easier, much faster. I don't have to clean data. I don't have to do feature engineering, and I get the output right away. So this is what I'm going to be using. I just ran the report a while ago. Once I'm onto this platform, I'm just telling the system that, look, I want to be predicting churn, and this is my ID. And now you take care of everything. You build the model, you clean the data, you do the feature engineering, you do the hyperparameter tuning. I don't have the time to do all that. So please, system, take care of it. So once I run it, it will be running in a couple of minutes. I can go back to the report. I just ran it 3 hours ago. So I'm going to look at this report. These are all the metrics. I'm not going to look into all the metrics for right now. All I want is right now the probabilities. Okay, so I have the probabilities now. Okay, so I have the yes probability of everybody, like if they're going to be churning or not. Anything which is more than 0.5, that means they're going to be churning. So for example, this person has a probability of 0.6. So I'm saying that this person is going to be churning. This is what I get. So I have the probability for every customer now. But as I said, I'm also looking at doing survival analysis, right? So now I'm going to go back to this one. I'm going to create a survival analysis report. Again, I don't have the time to do survival analysis, run all of these models as I was discussing in survival analysis, then determining the right sensing, left sensing. I don't have time. So I'm using this platform of ours. So essentially I'm saying is, what is the duration feature? So in survival analysis, you either need to give the duration feature or the date feature. So date feature would look like the two date variables. So when the customer started and when the customer ended, Or you can have a duration feature, which is like basically the difference between the activation date and the end date. So in this case, I know the duration variable. It's called the tenure. So so if I go to the tenure, look, tenure is the months, is the number of months the customer is has been with us. So I defined the duration feature churn and what is the event. So in this case, the churn is the event. I start analysis. So yeah, again, I ran this survival analysis report a while ago, and this is what it looks like. So mean residual lifetime, an overall chart. This is what it looks like. Um, the features that are important, etc., etc. I'm just looking at mean residual lifetime numbers for now, which is nothing but the number of months remain until a customer churns from today. Today is 11th of November. So from November 11th November onwards. So I have this data set with me, Control C. Then I have this. Okay. Card. Okay. Now I'm just gonna round it off. Okay, perfect. So now look, when I started out, I had no idea if my customer is going to be churning or not, right? But now I'm not just predicting if they're going to churn or not with a probability, but as well as I'm giving out the expected lifetime remains until the customer churn. Okay, so for example, I'm looking at this customer. This customer has a tenure of 1 month. He or she just joined us very recently, and then they have a probability of churn, but they're going to be churning in next 20 months. So similarly, I look at something like, by the way, the MRL number. So you may be wondering that, okay, look, Harsh, this guy has a tenure of 34 months, and now I'm looking at somebody who's already churned. Okay, I don't have it in this data set. So I'm copying the original churn values as well. Okay. So, for example, you may be wondering, okay, Harsh, first of all, let me clear up on this one. For this guy, we had an accuracy of 80%. So that means 20% of the times we have the wrong prediction. So this guy, we are predicting that he will be churning, but he actually never churned. But as I said, 80% of the time the predictions are wrong. For this guy, the second person, we predicted him not to churn and he did not churn. So number one, the accuracy is 80%. Number two, what I want you to consider in mind is that there will be some people who've churned and there will be still some MRL, which is the number of months until they churn. So for example, this person, I'm looking at this person, we are saying, okay, this person has churned, the predicted is not churned, and this person has a lifetime of 14 months left. Now, this will happen because just like the churn modeling, we have an accuracy of 80%. In this case, we are predicting it to be how many the months the customer has left with. So there's going to be some things will be off. So in this case, we predict it to be 14 months, but you say this guy has already churned. So we'll be looking at the people who've churned only. For example, this person 5 months, because every person will have some MRL. Like it could be 4 months, it could be 60 months. Even the people who've churned, for example, this person in the sixth, she has churned. They have churned, but I'm still saying they have got 4.7 months left. So I'm just going to ignore the people who've not who've churned. I'm just going to ignore them for my analysis. I'm going to be looking at people who've not churned, because people who've churned, I cannot do much with them. So in this case, what I'm going to be doing is predicted churn auto. Actually, no, that doesn't help me. But anyways, now I have like every row by row, I have the predictions now. So now what next? Now I want to be coming up with a strategy that, okay, look, accuracy is 80%, not the perfect accuracy. So now I want to be understanding that, okay, so the people are churning. How do I reduce the churn? What is the action plan? So I'm going to be using a lot of explainability AI, which we use to understand the black box models as well as get an explanation to a causality, like why is something happening and what can be done about it. So I'm looking at the global explanations here. I'm looking at a summary. The contract is the most important variable. Let me just zoom in. The contract is the most important variable in determining churn. After that comes the tenure. After that, internet type, payment, stream movies, multiple lines, etc. So now you may say, okay, contract is important, but should the contract be month to month? Should the contract be 1 year? Should the contract be 2 year? So anything above zero indicates churn. Anything below zero indicates non-churn. So when the contract is month to month, we see the highest churn. Okay. When the contract is 1 year, we see churn, but not as much as 2 year. Similarly, if I look at the variable tenure, I can zoom in actually. Let me zoom in. Okay. So when the tenure is between 0 to exactly half a month, there is churn, but suddenly the churn rises from half a month to suddenly 1 month. There is very significant tick in the churn, and then it starts going down. See, starts going down. At what point does it become zero? That means at what point the tenure starts making the churn go down? At this point, at the 17 and a half months, I start seeing the dip in the churn, and like 70 months, the decline in the churn is even higher. So I can get an understanding of each variable. I can break down every variable and look paperless. Okay, so if the person is paying a paperless bill, then there is higher chances of churn. If they are paying it, if the paperless is equal to no. Okay, so if there is no paperless, then there is lower churn. So I can look into every variable. That's what I like to call global explanations. Now comes the local explanation part. Okay, so I'm going to be looking at, let's say, this person, and I want to understand. So what we are saying is essentially that actually this guy never churned. This guy has never churned. He has a probability of 0.277. So this guy is not going to be churning. Remember, higher the probability, more are the chances of the churn. But we are doing a wrong prediction here. We are saying, look, this guy is going to be churning 0.723. So why are we doing so again, 80% accuracy, but the factors that are causing this person, the predictions to be higher, the reason why this person should be churning according to the machine learning model, because he has a tenure of 1 month. Remember, I was looking at the graph when it was 0 to 1 month, there was high churn. So that is why the machine learning is getting wrong, because machine learning essentially has to pick a pattern and it picks the pattern which is followed most of the time. But for this person, the tenure indicates a very high churn. The contract, remember, month to month was a pretty bad thing. It was causing high churn. So contract month to month, very high churn. Payment, electronic check, very high churn. So the bars in the orange are causing this guy to churn, and the bars in the blue are causing the churn to go down. So internet type is equal to DSL, which are reducing their chances of churn. Monthly balance is low. Higher the monthly balance, more the chances of churn. So monthly balance is low. So this is equal to 29.85. It's causing the churn probability to go down. So this is how I can look at every individual variable. For example, let me look at this variable. So what we are saying is that actually this person did not churn. And we have this, so 1 minus 0.96 is 0.04. So we have a probability of 0.04 of churning. So that means this person has very less chances of churning, no chances of churning. So those blue things, tenure, 34 months. This is causing the churn probability to go down. Internet type, DSL, go down. Contract, 1 year, go down. Payment, mail check, go down. Online backup is equal to no. This is causing the churn to go up. But overall, the blue ones are much higher, as well as the intercept is much higher. So I can say that is why these are the values associated with this very person that's causing the churn to go down. So now I'm done with this local explanation. I've understood the factor. For example, for example, okay, let me look at this person. So this person is actually churning. This person and we're predicting it to be churn. So what is causing the factors that are causing this person to churn? Tenure is equal to 2 months, causing the person to churn. Contract month to month, causing the person to churn. Internet type fiber optic is causing the person to churn. So now what can I do? What should be the action plan? So as we noted, remember in the global explanations, we were looking at the tenure variable, lower the tenure, more higher the chances of churn, but I cannot do anything with the tenure or contract. So as I make the people switch to 2 year contract or 1 year contract, the chances of churn goes down. And since what are the most important variables? Contract tenure. So I'll be working from the top. I'll be going to the bottom, from top to bottom, and I'll be trying to influence the values of the people whichever I can. For example, tenure. I cannot change somebody's tenure. It's fixed. I cannot change. Yes, I can change the internet type. Sure. I can influence payment. So let's look at the payment. Can I influence payment? Where is the payment? Okay. So whenever there is electronic check, the chances of the churn go up, right? So what I'll do is I'll go back to my Excel file and I can create those logic to be done in the CRM. Actually, we give it out to the sales team as well. So you can have logic in the if-else statements as well. If somebody has a probability of churning more than 0.6, 0.7, 0.5, then what do you do? And if they are using electronic check, then make them switch to bank transfer, credit card, or mail check. Okay, this is how I can have conditions. If somebody has a contract, if their chances of churning are more than 0.5, and if they have a contract equal to month, then make them switch to 1 year, 2 year. How do you make them switch to 1 year, 2 year? Maybe give them an incentive. Look, 5% discount if you become an annual subscriber. And if somebody has let's say a 2 year contract and they still show a high probability of churning, then I'm just going to follow this hierarchy. So contract, tick mark, the best contract possible. Tenure I cannot change. Internet type, okay, let me look at the person's internet type. So if the person is using fiber optic, I'll try to make the person switch to DSL or no. I don't know what internet type is equal to no, but that's how I try to make it switch. And of course, I can give incentives. So you can have those if-else statements to come up with action plan. So let me get back to my screen. Okay, this is also a cool thing. Sharp plots, I call them. So on your right is churn, on your left is no churn, and the red color means higher value of variable. And we got this answer in this one as well, by the way. The thing that we were doing causal modeling, we got it in this one as well. But again, this is kind of just summarizing sharp plots. For example, if your monthly balance goes up, there is higher churn. If the tenure goes down, there is higher churn. So that's how I can have more insights on it. But I actually cover it in the causal modeling, by the way. Look, another thing. So I was looking at this variable called monthly balance, and then I saw that between $97 to $110, there's a spike in the churn. Look, when I zoomed in, I found high churn. So I'm going to be creating an if-else statements like whenever somebody's monthly balance is between $97 to $110 and they have a high probability of churning, let's say more than 0.8, send them 5% discount. Look, if you clear the monthly balance right now, our company is going to give you 5% discount so that you bring down the monthly balance and there are also reducing the chances of churn. Okay, I did this. Mean residual lifetime, super important. I now know when these people are going to be churning exactly. Okay, cool. Last thing, so we saw the automation of machine learning, we saw the automation of data cleaning, feature engineering, machine learning, model building, all that. But I can even have it further automated. For example, look, this is a churn score of somebody. This is a dashboard which we provide to our customers in our CRM. Look, Dante Little has 88% chances of churn. If you take an action plan today, her chances of churn will go down. This is how you should engage in a couple of days. This is all automated, and this is all coming from your data, like the customer's data, not from our. We are no consultants or gurus. We don't come up with generic advice. It's just the data which is speaking. So with that, guys, my time is up. I would like to say thank you. Any questions, any comments, anything you didn't understand that I can explain better, I'm happy to have the discussions. Open for question answers. Anything. Guys, were you able to see my screen, right? Because I was sharing my screen all the time. Okay, I'm just sharing the PowerPoint presentation with everyone, by the way. Give me 1 minute. Okay, perfect. Otherwise, it would have gone all waste. Like if the people were not here able to see my screen, like I would have to run this webinar again right now. But okay, I'm glad. So this is the presentation. If you want to have a look at it, if you want to review something, happy to have discussions if you didn't understand anything. Okay, so what is survival analysis? Cool. So a normal machine learning is you have the classification and you have a regression target, right? A classification is when you're predicting somebody will churn or somebody will not churn. A regression is when you're predicting somebody's income or how much they'll be spending with your with your company in next 5 years. So this is a normal machine learning model. There's a technique which has been getting a lot of popularity recently, in which what you're doing is you're remember the censoring thing that I was explaining you, that for a lot of people in the data set, we have no idea. They haven't churned. We haven't given them enough time. So in a normal modeling, that problem is not addressed. But in survival analysis, this censoring problem is being taken into account. As well as the only way I can get a mean residual lifetime, which is how long from today do I have until the event happens. The event could be anything: the customer churning, the deal being closed, the machine failing, etc. When is that event going to exactly happen? So this is what I mean by so this is why we use survival analysis. Now there are various models in survival analysis, like the Kaplan model, like there is life tables, there is even pi survival. I've seen many models. So you use one of those models and you find out which models are more accurate, and you use that MRL, mean residual lifetime. Okay. Am I clear? Anything you still don't understand, please let me know. Happy to have discussions. Guys, you can also add me on LinkedIn. My name is, you'll just find me, Harsh Gupta 04. If you just write Harsh Gupta 04 after the LinkedIn, you'll find me. So add me. If you have any questions, we can always, I can always try to answer you after the webinar, if the time doesn't allow. The other thing is we have weekly webinars every week. So if you want to attend such webinars, do follow our page, Cliently. You'll be notified every time a webinar is created and you'll be able to attend it. Also, I'm curious, how are you guys right now? I'm sure like your companies are doing something for the churn prediction. So what exactly is the process right now for you to determine churn and the action plans? Are you guys doing survival analysis? Are you doing churn modeling? Are you paying tens of thousands of dollars to consultants and the gurus and the chief churner crashers? So let me know what you guys are doing in your company right now. I'd be happy to know. Like, always curious. Also, this is my email. Happy to have discussions, anything around churn modeling. So if there are no questions coming, then look out for my email. I'll be sending out an email with the webinar recording and the deck. And if any questions, you can always reply to my email. This is my email. Okay, there are one or two questions coming up. I'll just take them. Okay, perfect. Thank you so much for attending. Great to have you. Okay, guys. Uh, Thank you so much. Thank you so much. Anything afterwards, like I'm available on LinkedIn, email. You can reach out to me anyway. Any question, anything, comment, anything you didn't understand, happy to help. Thank you, guys.